And we are live.
Hello, good evening, guys. Welcome to this, new series on data structures and algorithm, which we have planned. It's a kind of, a foundation course. Anyone who is a little new on this course, or who is trying to learn this, or who wants to come back and, get started with the data structures and algorithms, it will be beneficial for them. Before we get started, let me quickly introduce myself. So I am Vishwa Mohan, and I have close to around 9 years of work experience. Uh, Through this 9 year of time, once I got passed out from IIT I got chance to work in the different MNCs, right? For example, when I was passed from the IIT the first company that I joined was a database giant, which is Oracle, right? And then later on I moved to another domain, which was a payment, and in that also fortunately I'm a part of the company which is the biggest player in the payment domain, and it is PayPal, right? Post that I worked succinctly for the Amazon, and then I started working for Walmart Labs, which is again an e-commerce giant, and currently I work for one of the largest professional social networking site, which is LinkedIn. So fortunately, unfortunately, I have been able to work on all the pillars of the IT ecosystem which one's dreams to work for, and this has given me a chance to understand that what it takes to do big, to have to set a mark in this IT industry. So this is what I've been doing professionally, but apart from that, I have a knack for teaching. I love teaching students. Okay, so I've been helping students and professionals crack their dreams for some time now, and this is one of the biggest reason I'm here on this platform today, sharing my thoughts about how to learn this art of data structures and algorithm. Uh, get the expertise on it and what it takes actually, practically speaking. Like theoretically you will find so much information on the net, there's so many things, people have so many suggestions for how to learn stack different data structures, algorithm, and then go and crack the interview. But I'll try to keep it as practical as possible, try to give you more more common and the practical insights. We'll try to see that how it gets done, and this will be a series of sessions, right? So we have a plan of like 10-12 sessions around this, and we'll be covering few of the topics of the data structures and algorithm, and try to set a proper foundation from there, from where you can take you guys can take yourself from your own and get started. So with said that, I think let's get started. Before I start, I'll try to set a rule. We'll try to keep it interactive, so you guys can feel free to keep on sending your questions as much as you want, right? And wherever that you want. I'll try to pick those questions throughout the session also, and maybe at the end I'll try to dedicate few time where I can get the question from you folks, and we'll talk about that. Okay, so this is the rule of the session. If possible, try to have a pen and paper with you, or maybe a editor on your computer itself. Try to be hands-on with me. I'll try to keep this session more interactive and more hands-on. Just I'll not focus more on the slides, because what I personally feel it makes it boring. So I'll try to keep it as interactive and as hands-on as possible. So keep yourself ready with the pen and paper, and for the next 1 hour we'll be moving together in this field of data structures and algorithm. We're starting from the bilkul scratch, and we'll take it to the complete depth which is actually needed to ace any interview. Said that, let's get started. So today agenda is that I'll try to give you a little introduction to the whole course, that what we are planning in the whole course, what all things that will be converted. Then we'll talk a little bit about what data structure is, what is so much why every company is asking data structure and algorithm question, what is the rationale behind it. Like when most of the time when I interact with the students, one of the basic questions that everybody has, that is tree and dynamic programming actually being used in the company, or they are just for the sake of irritating students in the interview, right? There are so many questions like this, right? So we have to go on for this one, and once we understand what the data structures and algorithm is, then we'll start picking one of the topic one after the other. So today I am planning to talk about time complexity. Again, time complexity is a topic which I feel people take it for granted. Everybody understands and feels that they know what time complexity is, but through today's session I like to make sure that you actually understand what time complexity is, and you're not taking it for granted. And we'll see with an example whether you actually understand or you just tend to understand. So we'll try to bridge that gap. So this is all about the today's session. Okay, and since this is the first session, I like to set the expectations right. So what you guys can expect as a part of this course. So basically this course will be around 12-13 hours course. So we will go through 12 to 13 sessions, and these are the few points that I wanted to make sure that you guys understand now, since this is the first session, that what are the things that's gonna covered, right? So we'll start with a very basic about time complexity. We'll try to understand what it is, why it is needed, how do you calculate it. Then we'll move to the recursion. Again, recursion I feel is a topic, it's important in each and every part of the data structures and algorithm, right? Again, this is one thing which I feel that people take this for very granted, but the recursion itself is so strong that if you understand it fully, the different topics like dynamic programming, in which most of the people feel that is very tough, right? The chapters like graph, the chapters like tree, right? Or any other chapter as such, like including the sorting algorithm, linked list, stack, queue, everywhere you will find the application of the recursion. So this is such a huge concept, right? So we'll try to set the things right. So once we completed time complexity, the next we'll try to cover is all about recursion. Once we are done with the recursion, then we'll try to talk about the sorting, because again, sorting is something which is used across the different data structures and can be used in the different algorithms. So having a sound understanding of what is sorting, how do we sorting, right? The different kinds of sorting, I think again, it will help us to understand it better. Once these three basic foundation is done, we'll start with the actual data structures. So we'll talk about the arrays. So basically throughout this session, we are trying to target the linear data structures. The first one in that will be the array. We'll talk about what it is. And then we'll try to see that what are the areas in which array cannot help us or it cannot work out. So we'll move to the another kind of data structure, that is linked list. Once we're done with the linked list, we'll talk about the stack, and then we'll finally talk about the queue. So these are the topics that we are planning to cover, but you as a student, I think you should also have some expectation, right? So if you are actually devoting your next 10 to 12 sessions or 12 days on this data session algorithm, what are the things that you can expect out of it, right? So the first and the most important thing that you should expect is that once you are going through all of these sessions, one thing that I can guarantee you is that you will actually appreciate what data structure and algorithm is, and you will appreciate that why I need to read it, right? So this is the one thing that I can guarantee you. The second thing that I can guarantee you is that you will now know that, what it takes to crack any coding round, and at the same time, why it is that, so many companies, like every company you see these days, whether small company, middle company, big company like Google, Microsoft, right? Why they emphasize so much on the data structures and algorithm? Why Google is asking, every 3-4 rounds is asking only questions on data structures and algorithm? Can I not just learn the technology and be a good developer? Why it is the need of a data structures and algorithm? So this doubt, if it is there in your mind, it will definitely go away, right? The third thing is that I'll try to bring practicality into this. I'll try to keep theory as minimal as possible. I'll try to bring more practical aspects of it. So one thing that again I can guarantee you is that you'll understand practically and intuitively that when to use stack, when I will use array, in which kind of situation I should use go and linked list, right? And so you'll have that understanding that which data structure has to be used in which kind of conditions. The fourth one that you can expect is that once you have done all these sessions, I think you must feel more confident as a software developer, or if you are a student, you feel more confident applying for the interviews. And if you are just practicing questions, you will feel that, now you have a better sense of intuition, when to apply the data structures, when to apply the algorithm. You will have a better acumen to understand the problems. Fifth, also, I'll try to, if you go through each of this, I think you can also expect to have an increased interest in the coding. One funny incident, I was also similarly, I was taking one webinar a few days back, and which one of the student asked that, I want to work in the IT industry, but I don't have interest in the coding, right? So this is a very, strange situation in which you want to do a job in the IT industry, but you don't have an interest in the coding. So I'll make sure that, we'll keep it as practical as possible. I'll keep on sharing my experience that I had throughout my RT journey, right? How I started as a beginner, and now it's like 9+ years of experience working in the IT industry, all the ups and downs, and the perks of working in the IT industry, so that maybe those points will help you, to motivate and boost yourself, and that maybe that can help you to have an increased level of interest in the coding, right? And the last, and but not the least, the most important point that I want to focus on is that after these few sessions, if you can promise me, like, for the next few sessions, you will take this sincerely, you will read this, whatever assignment that I'm giving you, we will do it, right? I think you will have enough foundation from which you can take it yourself, right? You don't need any coaches, you don't need to do anything. You can just you can take it from here yourself. Like, you understand that what is needed, you can take it from the internet and can start picking it from there. So these are the things that you can expect at the end of this course. If you have any questions around this, you can feel free to message on your chat box. I'll try to pick up as and when I get your messages. In the end, I have dedicatedly put some minutes to go over your questions. Cool. Great. So let's move to the first topic. Since we are just starting the course on the data structures and algorithm, let's try to first understand what is data structure. First, let's talk about what is data structure. Okay. So the first thing that I want to talk about is, what is data structure? In a nutshell, if I have to say, suppose if I have a computer, okay, suppose this is a computer, right? On a high level, a computer solves only two problems, or in that sense, whether it's a computer or whether it's a tablet that you have, or if you have any supercomputer as such, right? On a high level, a computer solves only two purposes, right? First of that is that, storage of the data. And the second one is the computation. Right. On a high level, whatever computer it is, maybe your laptop, my laptop, servers which is running on the Amazon AWS, Azure, anything. On a high level, any system that you see solves only two problems: the problem of the storage and the problem of the computation, right? And to the core of every storage and the core of every computation is something called data, right? The data, these days, you will always hear that everything is about data, right? A very famous acronym that, data is the new oil, right? Or in other words, if I have to say, people are moving towards a data-driven decisions, right? This is a new buzzword. Like 5 years from now, when the industries has to make any call, it was more based on their theoretical understanding. It was more based on their intuition, and it was more based on their expertise in their industry, right? But these days, with more and more companies, with the more advancement of the technologies, right? People are striving towards a data-driven decision. What it means is that if they have to take any decision, it should not be based on some gentleman's thought, or it should not be based on somebody's intuition. It should be more based on the data, right? So for that, data has become very important these days, right? So everything that we do emits the data. For example, say you go on Facebook, right? In a Facebook, when you click on a comment, or you like someone, or you scroll somewhere, or even if you hover over a link for a few seconds, right? Everything of that gets tracked. And what it means is that, since your activity is being tracked, it is resulting in, petabytes of data getting generated every day, right? And this is just not for about you. Every user who goes on the Facebook, I'm just taking example of the Facebook, right? It is true for every other website where you go. For example, take Google, right? The Google is in a phone. Everything that you do, even if you go to your, neighbor's house, even that movement of yours is getting tracked. So everything that you do these days, that emits a hell lot of data, right? And that emits a hell lot of data. And so we have to have something to, take the meaning out of it, take the meaning out of it. So how will you take the meaning out of it? First of all, we need to have the storage of that. So as soon as I collect the data, I need to go and store it, right? I need to first store it. And once I have stored the data, I should, able to bring the meaning out of it, right? Just having data will not make any sense, right? For example, just having books in yourself will not make any sense unless until you go and read it. Similarly, just storing data will not make any sense. We'll have to run the computation over it, right? Run a computation over it. So that is where the data structure comes into the play. That is where the data structure comes into the play. So as you see, data structure is self-defining itself. There are two terms in the data structure: data, and this whole world is going gaga over the data as of now. And the second term, which is structure, is what that is very important, right? So when we put a structure to a data, that is known as a data structure. In other words, when we arrange the data, that is known as the data structuring, right? This is known as the data structuring. Take for example, again, suppose you go to a pharmacy shop, okay, and you look for any particular medicine, right? What a pharmacy shop person do, he goes to a particular, rack. In that particular rack, a particular section based on the alphabet, and he just try to figure out where that medicine and give it to you. It's very simple. But suppose if that medicine shop or the pharmacist guys has not arranged all the medicine at the, in a proper order. If suppose all the medicine has been thrown in a single room, do you imagine that will that person be able to get you that medicine in the time? No, it's not possible, right? So similarly for the data also, we just don't need to store the data, but also have to retrieve it later to find the meaning out of it, to find the computation out of it, right? So that is why a data also has to be structured properly. It has to be arranged in some order so that whenever we need, we can read it back, we can retrieve it back and take the meaning out of which is actually the ultimate purpose of storing the data, to bring the meaning out of it so that we can take a data driven decision. So this is the reason why, what is data structure? So data structure is about, how you structure the data. And why do we need the data structure? So that, the first important point, why do we need it is that for the efficient storage, right? So if we can structure the data well, we can store it more efficiently. It will take less space, right? For example, if whenever you are, arranging your traveling bags, right? If you don't arrange your clothes properly, you will see that it will take more space, right? I'm just giving you a synonym. But if you arrange it properly, in the same bag, you can arrange more number of clothes. The same is true with the data as well. If you just keep stumping data on a hard disk, it may take more space. But if you store it in a proper structured way, the storage will be more efficient. So this is one important thing that why we need the data structure. The second is, if we structure it well, we can do the fast query. Right? If we structure the data well, we know that how it is stored, right? So whenever we have to retrieve it, we can do it fast. As we can see, example, as I've already given you the pharmacy shop, since the medicines are arranged in the proper order, it's very easy to retrieve it. The same thing applies in the case of the data world as well. If we arrange the data properly, I think we can retrieve it fast. The third thing is that since data storage or data structures helps me to structure the data well, now I can store it efficiently, I can query it fast. So with this, now I can run some kind of analytics on the top of this data and try to bring the meaning out of it. And once I have a meaning out of this data, I can start doing the data driven decisions, right? So it helps in finding the insights. It helps in the finding insights, right? So this is one of the core reasons. These are the first three core reasons because of which so now we understood what data structure is, and we have also understood that why do we need data structure, right? So normally we need data structure for efficient storage so that we can store data in a more efficient way. We can do the fast queries, and with this we can find the insights so that we can take a data driven decisions. I'll try to pick a few questions so far that has been asked. Okay, so I'll pick the one question. This question is that how important is the knowledge of data structure to become a software development integer? So as I said, as I've already mentioned by now, I think it should be already clear that the center of any industry these days, right, whether it's a startup, big or a small scale company, they all are moving towards a data driven decision, right? And they can only take this decision well if they know how to play with this data, right? And to the core of playing with this data, whether you are a simple software developer or you're working on the complex scalable systems, or you're a big data engineer, you're a AI machine learning engineer, at the core of everything is the data, right? And you need to know how to efficiently store it, and you need to know how to do the computation out of it. So said that if you really want to do justice to your work and you really want to achieve some stage in which you feel that, I want to do some kind of considerable work, I think data structure is a must. You cannot ignore this in from your profile. Without understanding data structure well, I don't see a way in which, you'll be able to do justice to your work. You might be able to still get salary and work, but if you really want to, do some, really effective work, which make, in some scalable system with which you want to contribute, I think data structure is really something that you should work upon. Okay, so this is about data structure. So we have understood so far what is data structure, and we have talked about what are the advantages of data structure. Now the second thing that, I think most of you would have this in the mind is that, why companies ask DS algo questions. Right, this is a very common question. Like, in every webinar that I take, or whenever I talk to the students, they have this question definitely in their mind that, are the trees and graph only asked for the sake of interviews, or is there any use of it also in the industry? And other words, like, why people ask ESL go, why not they ask something else, right? So to answer this question, as the previous thing that I talked about also, contributes to this, but to again reiterate, right? So the problem that we are solving these days in any industry, right, in our IT industry, right, is very complicated compared to what we were solving like 5 years back. If you take like 5 or 10 years back, the computers were mostly used to solve numerical problems, mathematical problems, very little, and which required the arithmetic calculation or the computations. But now, as you see, right, with the advent of the internet, people using so much of internet, right, our problems have become much more complex. We have started solving the real world problems, right? For example, all the offline stores has come online thanks to the e-commerce. All the cabs and all has come to the online thanks to the Uber and the Ola for the cab aggregation sites. Anything that we do in the medical science now, we are trying to do the same thing, mimic it with the help of AI and ML, right? So every real life problem that we have these days, we are trying to mimic in the online world. So the problems have become very complex, and they are more data centric now. This is one thing. And secondly, with this stage, for example, if we work for a companies at the scale of say Google, LinkedIn, or Microsoft, right, every day when you work, you are working at a different level. You're trying to solve something which nobody has solved before, right? For example, I work for LinkedIn, and every day when I go to office, and sometime I get a problem which nobody has seen before, right? So how do I behave in that case, right? How do I react in that case? How do I solve that unknown? I will be only able to solve that unknown if I have my basics right. I know what data structure is at the core, and then only I can apply all my learnings over a period of time, and then try to solve this problem, try to solve this unknown problem, right? So any company who's hiring someone is expecting them to work in these kind of environments. The only thing constant in the field of the IT is change, right? You cannot expect already solved problem always to communicate, right? So you have to have that acumen to solve these kind of unknown situations. You should be able to understand what data is, and in order to solve this problem, you have to have this basic understanding, right? And this is one of the basic reason why people are judged on the data structures and algorithm, because this deals with arrangement of the data, the structure of a data. And if you have the clear understanding of this places you in a better position, where if you are brought to an unknown problem state in a company, right, you can go and solve it. So this is one of the biggest reason because of which people in any company, any good company, and for that sake, in fact, every company these days who are interviewed, they're asking data structures and algorithm in their interview rounds. I hope that makes sense. So I think for these sessions, there's another question that is there any prerequisites? So I don't see there is any prerequisite for this data structures and algorithm, at least for this course. And even for if you start from the basic, there's no prerequisite as such. The only prerequisite is that you should be aware of one language, and that language is not English or Hindi. One programming language, like it can be Java, it can be C++, it can be Python. And I understand, most of the folks of you must be working on the Java, because like 70% of the company these days work on Java. So I'll be taking Java as a medium to write the code here in the class. but you can feel free to write in the language of your choice. So mostly we'll be talking about the logic, because data structures and algorithm is more about the logic. So we'll be mostly talking about the logic. And whenever I'll be writing code, I'll try to use Java as a language to write the code. But you as a student who is following these classes can feel free to code in any language of your choice. It can be C++, Python, JavaScript, Scala, Golang, any language of your choice. I'm totally fine. Okay, I'll take one more question and then I'll move on. The question is that, is data structures and algorithm important for the analytics, right? Now, analytics in itself has a very broad definition, and people have made it very confusing, right? So see, analytics is what? Analytics about playing with the data and trying to make the meaning out of it, right? So based on your role, right? Based on your role, for example, if you are actually trying to build the analytical tools itself, right? In that case, actually, you are trying to build some kind of application or software which feeds the data and provides the insights, right? So there you definitely have to know what the data structures and algorithm is. Then only you can, structure the data. Secondly, you are those kind of people who are just actually, utilizing those tools. For example, you are using on the Tableau, right, to get the insights. In that case, you are just building the dashboards and all. So in that case, it may not be that needed. But said that, if you know what data structures and algorithm at the core is, I think it will still be helpful for you. You can still go and tweak the system. You can understand it better. You can realize why it is performing like that, right? So I feel, a basic understanding of data structure is very important for anyone who has to deal with the data. And in the current scenario, in the current context where everyone is taking data-driven decisions, directly, indirectly, if you are in an IT field, you have to be aware of the data structure ecosystem. Make sense? But said that, I'll move on to the next topic because we are running out of time. So second one is, so I've talked about the data structure, then let me talk about the algorithm, right? Algorithm. What is an algorithm? Okay, what is an algorithm? So I'll just try to give an, I'll take a, so for example, you are a person here. I'll take example, and suppose you have to go to the airport. Okay, so one way to going to the airport is, this is 1 point, this is 0.2, this is 0.3. So you go from here to here, went to 2, 2 to 3, and then you finally went to the airport. The another way to go to the airport will be, you go to the 0.5, and then the 0.5 you directly go to the airport. The another can be, you can go to the 0.6, then you go to the 0.7, and then you go to the airport, right? So from your house, for example, if you're staying in the Bangalore, from your house to going to the airport, there will be different ways, different permutation, combination of the road through which you can go it, right? So each of this permutation of a combination, right? For example, this way, right? Suppose if you put that thing on a Google map, and Google map says that this is one of the possible ways to go to the airport, right? So this way that you first go to the step 1, then you go to the step 2, then you go to the step 3, and then you finally go to the airport, will be one algorithm, right? So this is one algorithm. The another one is this one, right? You go to the 5 and you directly go to the 5. So this can be algorithm A2, right? So my problem statement here is how I go to the airport from my current house, and the different paths to go through it, right? So the different paths is the algorithm here. So in a simple words, if I have to define what an algorithm is, so algorithm is basically, steps taken to solve a problem. Okay, so for example, here there are 3 different ways of going to the airport. So there are 3 different algorithms, right? So a same problem can have the multiple ways of solving it, right? So there's a A2, A3. So I have a problem P which can be solved by 3 algorithms, A1, A2, and A3. Now the different algorithm, maybe some algorithm is better, some algorithm is bad, but a problem can be solved by the multiple algorithm. So what is the algorithm? Algorithm is nothing but the steps to solve a particular problem. This is the simple definition of the algorithm is. Okay, I have given a problem statement, and if I have to solve it, what are the different steps that I take to solve it will be known as the algorithm. So this is just simple. Let's keep it very simple. So this is what algorithm is. So with the different data structures, the different ways of, so as I said, we do only 2 things with the data: storage of the data and the computation of a data, right? So for the different data structures, there are different ways to store the data into the data structure, and there are different ways to do the computation on that particular data structure, and that different way is known as the algorithm, right? That different way is known as the algorithm. So throughout this sessions, we'll be talking about the different algorithms, different data structures, and we'll try to see which algorithm is better, which algorithm is bad. This is all what we talk about in the coming sessions. I hope this is clear. So with that, we have now understood what algorithm is. We have understood what data structure is. So now the next important thing that which I want to spend more time now is about time complexity. Okay, can I say this statement? Time complexity is the time taken by an algorithm to solve the. Can I say this? Please comment yes and no in the comments. To all the people who feel that this is right, time complexity is the time taken by an algorithm to solve the problem, are 100% wrong. And you don't have to feel bad about it. Actually, it is true for, I have been talking to so many students and professionals, and trust me, like, more than 70% of the students feel that the time complexity is the time taken by an algorithm to solve the problem. The reason because the time complexity is preceded by a word called time, but it is not the case. It is not the case. Time complexity is not the time taken by algorithm to solve the problem. But before I talk about what time complexity is, I have another question for you guys, and please try to solve this problem. So I have a problem P. Okay. So I have a problem P. Okay. And to solve this problem, I have two algorithms, two algos to solve problem P. The first algo is A1. Okay. And suppose T seconds to solve this problem P. Okay. And the same problem P can be solved by the second algorithm A2, and it takes T2 seconds. Okay. So I have a problem P, and to solve this problem P, I have two algorithms. A1 algorithm which takes T1 second, and there's another algorithm A2 which takes T2 second, right? And I tell you that T1 is less than T2. This has been given. It means, A1 takes less time to solve P than A2. So my question to you guys is A1 better than A2 in terms of time? Can you guys please answer this question? Right? Is it clear? So you have been given a problem P, and suppose to solve this problem, I have two algorithms, A1 and A2. A1 is taking T1 seconds, A2 is taking T2 seconds, right? And I'm telling you that T1 is less than T2. It means algorithm A1 is taking less time to solve than algorithm A2. So with this statement, can I make a statement that A1 is better than A2 in terms of time to solve the problem P? Can I say this statement? Please answer your questions in the comment. I'm just giving you 5-10 seconds to. Cool. If you say that, if you feel that A1 is okay, if you feel that A1 is better than A2, then you are wrong. We cannot make this statement. Now you will be a little surprised that why cannot? A is taking less time, A2 is taking more time. Definitely A is taking less time, so it is much better in terms of the time, right? Why I'm saying it's not better? It's not better because we don't have a clear idea that what A1 and A2 is. Okay. Now the time for any code, the total time of execution for any code depends on the multiple factors. One of the factor on which the time depends is that on what kind of operating system it is running, or on what kind of system resources it is running, right? So for example, say A1 is running on a very multi-core machine, the latest multi-core machine, and suppose A2 is running, say, like Windows Vista machine, a long back, like maybe a 5 or 6 years old machine, which was a single core processor machine, right? So obviously a machine which is multi-core, have a multi-processor machine, if I run an algorithm on that, and if I run another algorithm which is on an old machine, which is single core, slow performing, single processor machine, right? Obviously, the time that it will take will be more, even though the algorithm is better, right? So it depends on which kind of operating system that you are running, it depends on, right? The second thing is that, choice of the language. Few of the languages are inherently fast. For example, if you see most of the folks when they participate in the competitive coding, the language of their choice is C++, to some extent Java, right? The reason being is that, C++ compiles fast, it runs very fast. But in the same code, if you write in the Python, the execution time will be little more, right? Because it's a scripting language, right? So choice of the language also depends. So for example, A1 I wrote in the Python, maybe A1 I wrote in the C++ and A2 I wrote on the Python, right? So even though A2 was a better algorithm, since I chose a different bad language which has a more time it takes to solve a particular problem, my time, the total time that it will differ, right? So it also depends on the choice of language that you are using, right? So what we realize is that total runtime of an algorithm does not only depends on the the algorithm quality, but it also depends on the multiple factors, like on which particular operating system it is running, what are the the processors, how many processors are there, what is the language that we are using to write the code. There's so many factors that comes into the play which finally decides that how much time it will take, right? So if we just take time as a consideration to define which one is better compared to another, that will be not fair, that is not correct, because time is not the only one factor which is responsible for making sure that which algorithm is better than the another, right? So that is why I said that time complexity is not the measure of the time that it takes to solve a particular problem. Then now the question arises, then what is time complexity then, right? If it is not the time taken by an algorithm to solve a problem, then what is the time complexity, right? I think this must be coming to your mind, right? So basically we had to come up with a kind of definition of the time complexity which should be independent, right? So whenever we have to define the time complexity, right, it should be independent of the language, independent of language, right? So it should not be that if I write an algorithm, I say to someone, okay, I have written an algorithm which is better in Java but bad in Python. Or I cannot say I have written an algorithm which works great for C++, but if I write the same algorithm in say Golang, it will not work well, right? If algorithm is better, it means it's better in all the languages, whether you write in Python, whether it's set to C++, Java, it doesn't matter, right? If algorithm is good, it should be good in all the languages. So it should be independent. So our definition of a time complexity should be independent of the language, okay? And two, it should also be independent of operating system. I cannot say like this, okay, I have a Mac, it works great. So the algorithm that I have written works great in the Mac, right? But if you run the same code in your Windows, it should not work well because your operating system is not that great. Something like that, right? So again, when I say that, that is not something correct, right? If algorithm is good, it is good, right? It will be good. It will work equally well on my Mac. It should equally work on a Linux distribution. It should equally work in a Windows machine, right? So again, the definition of the time complexity should be independent of the operating system as well, right? So now with these things in the mind, how do we define the time complexity? So the time complexity definition, now I'm coming to the actual definition of the time complexity. The time complexity says that, the definition of time complexity says that, how the actual number of operations depend on the input size. So the time complexity definition says that how the actual number of operations depend on the input size. If the number of operations that I'm doing is independent of the input size, I say that the time complexity is constant. If the number of operations that I'm doing inside my piece of code is proportional to the input size, I say that the time complexity is linear, right? Let's try to take an example to understand it more practically, okay? So let me first write the definition of the time complexity in the top, and we'll try to relate it with an example. So it is how the operations, how the actual number of operations are proportional to input size. This is what a definition of a time complexity is. Now let's try to take an examples and find the time complexity of each of that, right? So I'll take one example. Suppose I have writing a method public void, and method is say hello. Okay, and it takes input say n. Okay, and inside this I am just doing system dot out dot print ln, and I'm saying hello students, right? Now what I see is that, in this, if you go and see whether n value is equal to 0, then also I'm only printing one hello student, right? Whether n is equal to 100, then also I'll print single time only hello student, right? And whether n is equal to 1 million even, right? Like there's so many zeros, still I'm going to print hello student only one time, right? So in this case, based on the input size, the number of operation, what is the operation that is happening? This is the operation happening, which is only one. So in this case, the number of operation is independent of the input size that we are passing in the method. Whether the value of n is 0 or it is 100 or 1000 or 10,000 doesn't matter, right? So that is why in this case, I say that the time complexity is constant. Time complexity is constant, and this is how I indicate like this. So this is mean as the time complexity is and this is known as a big of O. Now there are different terminology like small o, big O, medium O, and all that stuff. To be very, so those are the theoretical aspect of that. I don't want to go deep dive into those things because I don't think it much make it, it makes more sense because you don't have to write any examination, right? You should have a practical understanding, and it should be relevant to what you need in the actual interviews and what you need to know when you're actually working in the practice, right? So basically, whenever you have to talk about the complexity, you talk in the terms of big of O. Big of O means what is the worst case time complexity? Like, if I have to do something, what can happen in the worst case, right? So basically, big of O indicates the worst case time complexity, and it is saying that in the worst case also, even if the n value is 1 million or 1 crore or 1 trillion, whatever high the value of n is, this method will always execute one statement, which is hello world, and so is the time complexity is. So the time complexity is constant, right? Let's try to see another simple example, and then we'll move further. So suppose let's try to divide this into the two halves, and let me see the question meanwhile if there's any relevant questions. Okay, so suppose I take another method, say void, and say hello. Okay, and I take int n. Okay, and this in this what I do, I have write a for loop for int I equals to 0, I is less than n, I plus plus, and I write, I simply just I'm writing a pseudocode, so I'm printing hello student. Right. So now if you see here, right, now for each value of the n, if suppose n value is equal to 1, in that case it will print, hello student will be printed one time, right? Because for value of n, I'm writing this for loop, right? And this for loop, it is running till the I value is less than n. So based on the input size, if n value is 1, the hello student will be printed 1. If n is equal to 100, this hello student will be printed 100 times. Right? And similarly, if I keep on increasing, this will also keep on increasing, right? So what we see here is that based on the input size, as we increase the size of the input, the number of times we are printing the hello is also increasing linearly, right? It is directly proportional to the input size, and that is why we here call it the time complexity is order of n. We call it the time complexity is order of n. Let's quickly see another example, and I think it will make more sense. And then we'll take one. Right, so for example, here again, if I write a statement void, and then I write print hello, int n. And now if I write, for int I equals to 0, I is less than n, I plus plus, and then inside there I write a nested loop which int j equals to 0, j is less than n, and then j plus plus, and I write here print hello, right? So in this case, if you see, right, in this case, if you see for each value of like the n, right, the outer loop runs for the n time, and for each value of the outer loop, the inner loop also runs for the n times, right? So basically, effectively, effectively, the number of times the hello gets printed is n square times. So for example, if n is equal to 2, the hello will be printed, for 4 times. If n is equals to 3, hello will be printed 3 into 3 times, which is 9 times, right? If n is equal to 100, hello will be printed 100 into 100 equals to 10,000 times, right? So basically what we see here is the number of operation that is happening inside this is proportional to the square of the given input size. So here I said the time complexity is O of n square. So with this, what we have realized is that whenever we have to find the time complexity, the time complexity is always, what is time complexity? Basically decides how many number of operation that you're doing based on the input side. This is the definition of a time complexity. Now let's try to solve a problem, and I think you guys should solve a problem with me. So problem statement goes here. So I think by now we understood what time complexity is, what is the definition of it, and based on that, let's try to solve this problem. Okay. So suppose I have a loop like this. Suppose for int I equals to 1, I is less than n, and I is equal to I into 2. Okay, like this it is. And inside this, I'm suppose printing hello students. Okay, suppose this is my code snippet. Input sizes is equal to 1. Can you tell me what is the time complexity? Can you tell me what is the time complexity of this one? Okay, so in this question, what we have given is that we see that I value is 1 and it is going till n, and I value is getting multiplied by 2 every time, right? And this loop will keep on running till the value of I is less than n, and I'm printing the hello students. Okay, just try to solve the time complexity along with me. Okay, so how do we approach it, right? So as soon as we get a time complexity problem, right, I think we first try to define what is the definition of a time complexity. The definition of a time complexity is based on the input size, how many number of operations that you're gonna do. The input size is n, right? So I have to see how many operations that I have done, right? Here what I see is that I is getting incremented by twice every time. So for example, initially I value is 1. The second time it will go to the loop, the I value will become 2. The third time when it goes, the I value will become 2 into 2, which is 4. The third time when it goes, first time it was this, second time it will this become this, third time it will become this, fourth time when it goes inside it will become 2 into 2 into 2, right? Like this it will go, right? So what I'm seeing is that instead of I getting incremented by 1, it is getting multiplied by 2 every time, right? So one thing that I'm very sure is that the number of times for loop will run will be less than n, right? And so one thing with this, since I is getting incremented, is becoming twice every time. So one thing that we are very sure is that the number of times this for loop will run will be always less than n. And what is the time complexity? The time complexity actually is how many times the number of times the for loop is running. This is what the time complexity definition is. So let's say for loop runs for k times. Let's suppose the for loop runs for the k times, and one thing that I'm very sure is that k will be less than n. K is the number of times the for loop is running, and k will be less than n because every time I is getting twice. If I was incremented by 1 every time, it must be equal to n. But here the situation is different. The I is getting multiplied by 2 every time, so the value of k will be less than n, right? So let's see, so as I said, the first time when it goes inside the loop, the value of I was equals to 1. The second time it went inside the loop, the value of I became 2. The third time it went inside the loop, the I value became equals to 2 to the power 2. The fourth time it went, the value of I became equals to 2 to the power, 2 to the power 3, right? So similarly, when it went for the k time, as I say that, the loop is running for the k times, the value of I would have become equals to 2 to the power k minus 1, right? This is what at the kth time the value of I will be, right? If k is the number of times the loop is running, so at the kth time the value of I will be 2 to the power k minus 1, right? And at this time, when the value, and k is the time, the number of times the loop is running, right? So the k plus 1th time it will terminate, right? And at the time when it terminates, it will be k plus 1th time, right? And at that time the value of I will be 2 to the power k, right? And this is the place when the value of I will become equals to greater than equal to n, because till the time the value of I is less than n, this key loop will keep running, right? So the time when it breaks out of the loop, the value of I would have become equal to greater than equal to n. And what is the value of I? The value of I is 2 to the power k, that is greater than equal to n. Okay. What we do is that now left part we have 2 to the power k, right part we have to n. So what we do, we take log both the sides. We take log, base 2 both the sides, both sides. So what will happen is that the left hand side become k, and this we can write like the log n, right? Now, whenever we have to talk about time complexity, we always talk about the proportionality, approximation. So this thing I can say that, k is approximately equals to log n, right? What is k? K is my number of operations, right? So what I see, the number of operation right now is proportional to the logarithmic time of n, and that is why I say that the time complexity of this problem will be order of log of n, right? So now no more you need to memorize that. I have seen students, they will tell the answer that, okay, this for loop has a time complexity of log n because I see it is multiplied by 2 every time. But when you go and drill them that why you say it is a log n, they will not be able to answer that. The reason is they have never understood it, right? So the only way to solve this problem or understand a time complexity better is to understand what the definition is. I'm again reiterating, what is the time complexity? The time complexity is how much number of operations that you're doing inside a function based on the input size. If you can figure it out, the number of operation compared to the the input size, you can always figure out what is the time complexity here is. Just for example, in this, what we said that we try to figure it out how many times the loop is running. We assume that the loop is running for the k times, right? And then we try to figure out how k is depending on the input size. So we found this relationship, right? And with this, I took the log both of sides, and then I found the k is proportionally equal to log of n, and that is why I said the time complexity is log of n, right? I think this makes sense. And going onwards, whenever you have been given any kind of situation where you have to find the time complexity, just don't. Another thing that, yeah, so I just want to mention it here. People normally tend to do one very big mistake. Whenever they see a loop, they consider it as a linear time complexity. When they ever see 2 nested loop, they will say it O of n square. When they say 3 nested loop, they will say O of n cube. When they say one loop in which every time the element is multiplied by 2, they call it directly log of n. But be very careful. Don't do it blindly, right? Dupatta dikhe to larki is not very important, right? Even a guy can be wearing a dupatta. Same thing here also. Just a loop doesn't make you guarantee you that the time complexity will be linear or the quadratic, right? So be very clear, right? Just try to see how many times the actual number of operations are happening, right? And only when you know what is the actual number of operations happening proportional to the input size, that is how you find the time complexity of a problem. So this is just one example. How do we figure it out? To all the students who have enrolled to this course, you will be getting an assignment in which I have given a curated list of 5-6 problems on the time complexity. Please give it a try. In the next session, I'll be discussing initial 5 minutes or 10 minutes. I'll be discussing all those questions there. You please try it. And if you are able to solve all the question, I think, a brownie point from my side, it's a really thumbs up. I will really appreciate. But if you solve those 5 problems, if you are not able to solve it, right, even if you try, I think that is more than enough. It will give you, it will take you a long way. You'll really appreciate the beauty of the time complexity. Later on, whenever you are any solving problem, you will never have any issues in finding the time complexity of anything. That I can guarantee, right? So if you're able to solve those 5 problems, my expectation is not that I want the answer. My only expectation from you guys is at least give it a try. And if you're able to solve those 5 problems, at least give it a try. And the next session, when I'm discussing about it, you listen to it. One thing that I can guarantee you is that you will never face any problem in finding time complexity in any of the questions. That said, I'll take few of the questions now, which has already been asked for me. I think we're already running out of time, but just bear with me for a few minutes. I'll take few questions. try to address that now, and we'll catch up again in the next session. So one question is, are you going to teach trees and graphs? So I think trees and graph are not a part of, is not planned as a part of this session. We'll be only covering the linear data structures and all the prerequisite that is needed, right? So the first prerequisite was time complexity, which we have covered today. In the next session, we'll be talking about recursion, which I again feel is a very strong topic, which is used across the data structure, right? Whether you're reading about sorting, whether you're running about different data structures, dynamic programming is needed. Then we'll start with the arrays. We'll talk then about linked list, stack, and the queue. So this is the domain. The first, we're targeting the the linear data structure as a part of this course. Trees and the graph will definitely come, but that will be part of the different course. So this is a kind of foundation, or a basic prerequisite that is needed to ace any interview. So the domain of this is not the graph and the trees. We'll be only covering till the queue. I hope this answered your question. Then. Which language is used mostly in the companies? So yes, so I think the Java is the most commonly used language these days, whenever you have to make any scalable complex situations. But Python also is is coming up very fast, because one thing is that its learning curve is very simple, and second, you can write less and do more in the case of the Python, right? So whenever you have to make any POC kind of thing, or you have to automate anything, or if you're working on the smaller projects, Python makes more sense. But if you're working on some highly scalable system on a big industry product, right, Java is more flexible and it provides more opportunities to scale it further. So I think said that both are important in their own words. But to answer your question in one word, yes, Java is most widely used still across the industries in the backend systems. So again, a question comes that how DSLGO helps in the automation testing, right? So they see automation testing can be of different types, if I understand it well. There's kind of white box testing, there's something called black box testing, right? So for example, you are doing some kind of API testing, right? So again, in the API testing, if you don't know anything about the data structures and algorithm, right, sometimes it will be very tough for you to make the actual structures of the data to write the proper test cases, or write the proper codes around it. But if you understand under data structure, you can better appreciate the underlying data structure that might be used by the developers to develop that code, and then maybe you can write more comprehensive coverage of that particular use case, right? If you know better how that code has been implemented as a tester, I think that way you can do more justice to your testing abilities, and you can do a more thorough testing. So that is one thing. Secondly, if you are developing a kind of test suite, you need writing multiple tests, right? At one moment of time, you will also be looking to reduce the testing time without compromising on the testing quality, right? And that is only possible if you know how to write more optimized code, right? So in that case, also, if you have a good understanding of data structures and algorithm, when you're developing your testing suits, a testing framework, you can use those acumen to write optimized code, so that you are still maintaining that quality, but at the same time, the time that it takes to run all those tests also comes down, right? So if the time that it takes comes down, it will help you to debug, find the problems much faster and quicker. I hope that answers your question. Then the question is, how is data structure different from the data science? A little different. Both has the data in it, and that is why it is so important. The data structure talks more about how you store the data and how you query the data, right? How you query the data. The data science is more about, once you have queried the data with you, how do you bring meaning out of it, right? So the work of the data science starts from the time the work of the data structures ends. So both of them works in close hand to hand. Data structure helps you to store data efficiently, query it fast, and once the data has been queried fast, you can use the data science on the top of it to bring the meaning out of it. Learn your machine learning models, bring the intelligence into that, predict something out, and then again generate more data, right? So both data structures and algorithm and data science works hand in hand. They're not competing, but they're complementing each other. I hope that answers your question. Yes, so this step-by-step path to master DS and algo. So actually, yes, this is very important, a very nice question. I think in the internet these days, the plethora of information. There are so many sites, and every organization is actually claiming that I can help you ace your data structures and algorithm. I'll make you master in that. Let me tell you one thing, unless until you have yourself done something, it's really tough to teach someone, right? Back into my IITs days also, when I was, I strongly believe unless until somebody has done something on their own, how they can preach something out. But this is how they're in the internet. Everyone is teaching, everyone is giving advices, and there are so many websites around which are like thousands and thousands of questions. So what I've seen students that they normally get fall prey to these, or they only end up different kind of websites which have like thousands of the problems. For example, if I take example of Geek, I don't want to quote, but I just example, if I take the example of Geeks for Geeks, right? They have like 10,000 of questions, and practically, if you ask me, it's not practically possible for anyone to solve all those questions, right? So normally what, and also there's no proper order of the questions, like order of the complexity. So what happens is that, a student jumps to the Geeks for Geeks, that okay, I'll solve the start problem from the Geeks for Geeks, and they suddenly find a problem, and they're not able to solve it. They're not able to solve because they don't have enough concept clarity around that topic. But what they realize is that okay, I'm not able to solve, I'm not good enough, and that that vicious cycle of uh, demotivation kicks in, and people start feeling that, oh, I'm not built for data structures and algorithm, I cannot do this, I cannot learn this, I cannot crack jobs like Google and Microsoft. They are the different set of people who can do it, but I can't. But this is not the truth. The only reason you're not able to solve is that you've not done it right? So a path is very important. A path to solve a data structure algorithm problem is very important. So you have to do in a systematic order, right? So this is what we are trying to bring as a part of this course, which is totally free for you guys. The only thing expected from you guys is to stay sincere and stay relevant and try to follow along, follow along with us. If you follow this path, one after the another, that is how we are trying to do. You don't have to do anything, just try to follow this path, and slowly and slowly over a period of time, you realize that you are a totally different changed person now. The confidence that you were lacking in these subjects, slowly you will figure that you are more confident now. You can track any question, right? So so to answer your question in a nutshell, we are actually trying to do the same thing. As a part of this whole coursework, we are planning to give you a pathway that what should be learned first and what should be learned next, and what should be the the sequence of that. Only if you do it in that particular sequence, I think that will be meaningful. Otherwise, what will happen is that you will start losing confidence, you get distracted, you will go to the different platforms, you will solve 100 questions from each of that. What happens is that if you follow the different platforms, you end up solving easy question on all the platforms, and all the medium and the tough one will be left behind. So it's always good to pick one and stick there and try to be there unless until you have solved all the questions on that, right? So this is what we are trying to bring on this platform. We'll be giving you the proper path, the insight that what you should be doing, so that the cracking the any interview. When I say any interview, including the Microsoft, Google, LinkedIn, becomes a charm. It should nobody be a challenge, right? So that is all. And trust me, it is not a rocket science. It's very simple. Getting a job in these companies is very simple. It's just that you have to follow few steps in the right way, right? In the right and the optimized way. If you do that, I am also breathing the same air, and I'm also having blood in my body, and same thing is with you, and you're also having 24 hours, same as what I am. If I can do it, I can trust you, you can do it too, in a much better way, because we have more resources. The people in this generation have more resources than what we had few years back, right? So I think you are in the best position right now, and I think you should make the best out of this whole situation, again, because there's a less distraction out there for the next at least 30-40 days. Try to make the best out of it, and I see there's no reason why you shouldn't be into one of your dream companies. I hope that answers your question. How to calculate the space complexity? Yes, so I think this topic was supposed to be done. Since we are running out of time, so I have skipped this. So this is the first thing that I'll be taking up in the next session. We'll talk about the space complexity, but the idea of the space complexity is same as the time complexity. And if I compare with the space complexity and the time complexity, space complexity is given a less importance because no one is caring about the space these days, right? Space is the cheapest thing to have in the today's scenario, right? We are talking about the big data, right? In which you're storing huge amount of data with the replication factors, right? So space is no more a concern. So even if you have a high space complexity, it's not of much importance. The important thing is time. So that is why I emphasize more on the time complexity today, and we solve problems around that. Space will be taking up in the next session. Yes, the mind research will be covered as a part of this. Dynamic programming is not a part of this curriculum. There's another course going in the parallel in which we'll be talking about that. So maybe you just follow around that, and we'll be covering the dynamic programming in the another session. I think I have covered most of the questions that I had. We are well ahead 10 minutes from now. So before I shut down for the today, a small request. So you guys who all have registered for the Great Learning course, you'll be getting a list of questions. Please give it a try and be ready with your solutions by Monday. on Monday 7 p.m. we'll be catching up again, and we'll go through your doubts in the beginning, and we'll move to the next topic, which is recursion. So try to read about the recursion as much as possible, because that way you will be able to ask more focused doubts, more relevant doubt. And yeah, that's all. Try to make the best out of it, and I think this is the situation which you should take as a blessing in disguise. And I think this platform has brought this great initiative in which you don't have anything to lose, right? You're not paying anything, you're getting it for free, and you should try to make the best out of it, so that after this next 3 to 4 weeks of time, you can find yourself as a better developer, as a better student, who understand data structures more practically and more well. Said that, that's for the day. If you have any question, I'll be more than happy to answer. But I think that's for the today. Stay safe, guys. Stay indoor. Thank you.